Good morning, class. Today we're going to look at the areas of trapezoid, rhombuses, and kites. We already have 4 formulas in our toolbox. Only 3 unique ones, really, if you ask me. Maybe even 2 if you argue it. But we have 4 formulas that we've learned in the last section. We're going to be adding on to 3 more formulas. And that's going to be 1 for trapezoid, 1 for a rhombus, and 1 for a kite. Real quick, if I look, rhombus, isn't that technically a parallelogram? And it is. So when I look at the formula for parallelogram, I should be able to use that for rhombus. But there's another case in the rhombus, and that's why it's actually given its own section here for finding its area. The first thing we're going to look at is the area of a trapezoid. The area of a trapezoid is going to be 1/2 the product of the height and the sum of the lengths of the bases. Alright, so if we look at the screen here, if I have a height, which is going to always be perpendicular to both bases, if I take this height and multiply it by half, and then multiply it by the sum of the bases, so if I take the bottom base and the top base and add them together, I will get the area. Now let's kind of justify why this formula works. If I look at a trapezoid here, the formula ends up being A equals 1/2 H times B1 plus B2. Now, the justification for this is that we essentially cut this in half. And we take this and flip it over. So that way I get a shape that looks like this. Each side length would be B2 plus B1, because right about here we have that division. This is where I turned it over. This bottom part would be B1 plus B2, or B2 plus B1, it doesn't matter which way. And this height would be 1/2 the original height. And, well, we already know that these sides were parallel to begin with. However, what ends up happening is that this side and this side would also be parallel. So I'd have a parallelogram. And the area of a parallelogram is just the base times the height. And in this case, the base is going to be the sum of the 2 bases that I started with. And the height is going to be half the height I started with. So this is just a real quick justification of why this formula works. Because we can think of it that I cut this trapezoid in half, flip it over, and make it into a parallelogram. And then I just use the area of a parallelogram equation to find it. However, this is the formula we're going to be using. A equals 1/2 B1, A equals 1/2 height times the quantity, base 1 plus base 2. Alright, now that we have a new tool in our pocket, let's get the last one out of the way. So that way we have all the formulas right off the bat. Here we go. Area of a rhombus and a kite. Now, just like before, I've said this once or twice in the last video, where we can only find area when we multiply stuff that is at a right angle. Even in the last example, I said that the height had to be perpendicular to both bases. And in all the examples yesterday, all the bases and heights had to be perpendicular. So if I look at this one here, what happens in a rhombus and a kite is that their diagonals are perpendicular. Well, their diagonals are perpendicular. So if I would draw, let's say, a kite or a rhombus, with the diagonals being perpendicular, if I multiplied them, I wouldn't get the shape I'm looking at. Because if I would multiply them, it'd be like as if I was multiplying this big shape that I'm going to be drawing here in red. It would be, for instance, this could be diagonal 1, and then this would be diagonal 2. And that's not the area I'm looking for. But what I do notice is that, hey, just like before with the triangles, this part here is a right triangle, and it's half of this rectangle area. This right here is a right triangle, and it's half of that square or rectangle area. This right here is a right triangle, and it's half that rectangle area. This is a right triangle, and it's half of that rectangle. So wait, each part of my rhombus is half of its corresponding region. So then, if I multiply the diagonal 1 times diagonal 2, so if I multiply the 2 diagonals times each other, and I take half of it, I should get the area. And that is what both formulas for rhombus and a kite are. It's A equals 1/2 the diagonals multiplied by each other. That's it. And the justification is this type of ideal. If I take the diagonal 1 and multiply by diagonal 2, I get the area of this big rectangle here. And, well, each of these right triangles are going to be half of that rectangle area. So when I look at it in total, the kite or rhombus is half of this rectangle's area when I multiply diagonal 1 times diagonal 2. So I have another formula to find the area of a kite or rhombus. So I now have a total of 6 formulas, maybe 7, depends on how you look at it, to use to find area. And all I have to do is pretty much match up the shape and I should be good to go. Example 1, just straightforward, find the area of each shape. So what we're going to do is look at each problem, identify the equation we're going to use, and find the area. Alright, so for number 1, let's just identify the shape I'm looking at. Well, it's a trapezoid. Wait, how do I know that? Well, this is perpendicular, and this is perpendicular. Wait, I have 2 line segments that are perpendicular to the same line segment, so that means this side and this side have to be parallel. Oh, and if only one set of sides are parallel, it's a trapezoid. Now, honestly, I don't know if these are perpendicular. Actually, I probably could tell. If these are perpendicular, and this is 8 feet long and this is 6 feet long, there's no way this is a right angle here. No way at all. So I know with 100% certainty it's a trapezoid. So first step, write down the equation. 1/2 h times base 1 plus base 2. So I'm looking for area. So A equals 1/2 h. Well, the height ends up being this length right here, 4 feet. So I put in 4 feet. The base 1 and base 2, it honestly doesn't matter which one I choose. I could choose 8 as base 1, I could choose 6 as base 1. But put 1 in for either one, and put the other one in for the other one. So I'm going to put 6 feet in for base 1, and I'm going to put 8 feet in for base 2. Now the reason it doesn't matter is because if I follow my PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, first thing I have to do is the stuff inside of the parentheses. So A equals 1/2 4 feet times, well, 6 plus 8 is 14 feet. Now it's all multiplication, so it doesn't matter which order I go. I can do 4 times 14 first, or I can do 1/2 times 4 first. For me, I think I like the 1/2 times 4 first, because I get 2 feet times 14 feet. And when I multiply those two together, the area is 28 feet squared. And done. Number 2, I'm identifying the shape. Well, based on the markings, not on my drawing ability, I see I have 2 consecutive sides that are congruent. According to the labeling, this is a kite. Now, depending on the situation, it might be a rhombus. However, we're going to assume that it's a kite, but it wouldn't matter either way. It's the same formula. So I look at the formula. It's A equals 1/2 diameter 1 times diameter 2. Oh, 6 inches is one of my diameters, and 14 inches would be my other diameter. It's not drawn, but it would be the other diameter because it's the width of my kite. So in this case, it doesn't matter where I put D1 and D2 because they're both diameters. 6 inches for one of them, 12 inches for the other. Sorry, 14 inches for the other. And again, because it's all multiplication, order doesn't matter. 1/2 times 6, 6 times 14, doesn't matter which order I go, but I choose. 1/2 times 6 is where I decided to go, 3 inches times 14 inches. And what I end up getting is 42 inches squared is my area. Alright, 2 problems down. Third one left. Again, identify the shape. Well, I see 4 congruent sides, automatically rhombus. So I know right away area equals 1/2 diagonal 1 times diagonal 2. Well, diagonal 1 is a 30 and is a 40. Yeah, I'd say so, except for there's one slight issue. 30 inches is only marking this part right here. So that means this part down here should also be 30 inches. Wait, so the full diagonal isn't 30, it's 60. And same thing with 40 here. 40 is only marking half the diagonal, and 40 ends up being the other half because it is a rhombus and the diagonals are cut in half. Alright, so when I plug it into the area equation, it's 1/2 60 inches times 80 inches. Again, it really doesn't matter which way I go, it's all multiplication. A equals 30 inches times 80 inches. And then area is equal to 2,400 inches squared. Good thing they didn't want me to convert this, otherwise it would be a little bit of a nightmare, but we can do it. And there we go. I found all the areas. Real quick, if you don't know how I knew that this was 40 and 40 and 30 and 30, this is a Chapter 8 issue. Go back and review Section 2 of Chapter 8. Alright, that's it for example 1. These aren't the only type of questions I might ask. For instance, I might ask, what if instead of giving you the area, instead of asking you to find the area, what if I gave you the area and said, hey, find one of these unknown lengths? Just to be clear, y is labeling the full diagonal. 7 feet is labeling the full diagonal in the upper left picture. The 12 centimeters is labeling the full diagonal, not just half. And everything in the bottom picture is fine. You should be able to figure that one out. But I just want to clarify that it is labeling the whole diagonal and not just half. Alright, and now that I've recopied all these pictures, again, the first step in these problems is because I'm looking for the variable, and I'm given area. I know it's very likely I'll probably have to use the area equation. If they give me a perimeter, I'd probably have to use a perimeter equation. If they give me an area. So I look, this shape here, I forgot to put labels on it, but it is a kite. So if this is a kite, there's only one formula that I know to find its area. That's A equals 1/2 diagonal 1 times diagonal 2. And then I fill in what I know. I know the area is 56 feet squared. I know diagonal 1 is 7 feet. And I know that the other diagonal is y feet. Now, you have multiple options. You could do 1/2 times 7 first. You could divide both sides by 7. You can multiply both sides by 2. But the way I'm going to choose is that I want to get rid of the fraction. So to do that, I'm going to multiply both sides by 2. 1/2 times 2 is always 1, so it essentially gets rid of my fraction. And 2 times 56 is going to be 112 feet squared. Equals 7 feet times y feet. Divide both sides by 7 feet. And what I'm going to end up getting, 16 feet equals y feet. So y is 16. And there I go. That's all there is to it, is plug it into the equation and solve for my unknown. Over here, I look. 4 congruent sides, it's a rhombus. Alright, I have two choices. It's either A equals base times height, or it's A equals 1/2 diagonal 1 times diagonal 2. I look at what I'm given. I'm given a diagonal, and diagonal is what I'm looking for. I'm given area. It makes a lot more sense to use this one than this one in this case. But because a rhombus is a parallelogram, I had to consider it because it might have been the easier way. So 324 in for the area equals 1/2. It doesn't matter which one I choose for which, but I'm going to choose 12, then Z in that order. But it didn't matter which way I chose. In this case, because 12 is even, I think it might be easier just to do 1/2 times 12 first. I didn't like to deal with the decimal over there, and that's why I didn't do 1/2 times 7. But over here, 1/2 times 12 it's going to be nice because I get 6, and Z is Z. Divide both sides by 6. Z is equal to 54. Now, real quick, you might have noticed, over there I kept units in the whole thing, over here I didn't. And here's the thing, if all your units match up, you're fine to use just numbers. But it's when your units don't match up that you run into an issue. And that's why I kept it over here. Just because in this case where the units were the same, I would have been able to catch it a lot sooner. Here, the units were all the same, centimeters, centimeters, and centimeters squared. yeah, centimeters squared is over here, and centimeters times centimeters makes centimeters squared. So I said, all right, my answer will come out to be what I expect it to be, because all the units are right. So I ignored them. Just be careful if you decide to go that route, because you might get a wrong answer because you forgot to convert something. All right, and the last one for this one. Well, area, it's a trapezoid. How do I know? Well, I didn't label it. I really should have. But one set of sides were parallel. It was also because I forgot to label this as perpendicular. That would have also been the clue to you that it was a trapezoid. That was perpendicular to both. Alright, so it's a trapezoid. So automatically write down the area equation. Area equals 1/2 height times base 1 plus base 2. Don't want to know. I know the area over there is 264. Who do I have to worry about units? Inches, 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 inches. We're good to go. 1/2 times the height. 24 times base 1 plus base 2. Do I start with x or 8? Well, it doesn't matter. As long as I use both of them. 8 plus x. X plus 8 is going to be the same quantity. We're good to go. Well, I think in this case, I might want to simplify the right side first and then solve. So I'm going to leave 264 alone for a little bit. 1/2 times 24 is 12. And then that's going to be multiplied by 8 plus x. Time to distribute. 12 times 8 is 96. Plus 12x equals 264. Now that it looks like this, solve for x. Subtract 96 from both sides. Divide both sides by 12, and I get 14. There we go. So I can give you problems where I say, hey, find the area. Expect you to plug it into the formula and solve. I can give you problems where I give you the area and say, hey, find an unknown length. Plug it in, solve. This is going to be the main type of equations you will see. However, there are a few others you might. Starting with one like this. Word problem. Alright, as soon as I see this, I'll almost automatically know I'll probably be drawing a picture. I might not need to, depending on how well I am without a picture, but most of the time a picture does help us. At least to set up the problem and know what we're doing. So this problem says, one diagonal of a kite. Alright, first word that was important, diagonal. Second word that was important, kite. So right away I know to draw a kite. By the way, if you ever have trouble drawing a kite, draw this, a plus sign first, or some sort of cross, and then connect the corners. And you should have a pretty well drawn kite. And then you just mark what makes it a kite. There we go. So one diagonal of a kite is twice as long as the other diagonal. Alright, do I know either length? It doesn't sound like it. So I'm going to call this diagonal here. Actually, one diagonal is twice as long as the other one. Let's call this one x. I don't know what it is. So then it says one diagonal of a kite is twice as long as the other diagonal. One diagonal of the kite is twice as long as the other one. So 2 times x will be appropriate. If this is 5, that's 10. Awesome. The area of the kite I know is 72.25 inches squared. Alright. What are the lengths of the diagonals? Wait, what are the lengths of the diagonals? I'm given area, I'm looking at diagonals, it's a kite, so right away, throw down the formula. A equals 1/2 diagonal 1 times diagonal 2. And at this point, I think it's pretty clear what we should be doing. The hard part of this problem was understanding what it was saying. But once we do it, I think we're good to go. Because at this point, I think it's time to take out the blue to start saying I'm solving it. A equals 72.25 inches squared equals 1/2 times, it doesn't matter which one I choose, a diagonal 1 and diagonal 2, so let's do x and 2x. I'm going to simplify the right side. 1/2, let's do 2x times x first. So 1/2 times 2x squared. X times x is x squared. 2 times 1 is 2. So I look. Now 1/2 of 2x squared, well that's just going to be x squared equals 72.25 inches squared. And to solve for x, I have to take the square root of both sides. So at this point, you're probably going to need a calculator unless you know exactly what it's going to be. Now, if I had to take a good guess, based on the choices I have here, it's going to be decimal, probably something with a 0.5. And this number is between 8 squared and 9 squared. 8 squared is 64, 9 squared is 81. So if I already said it's something 0.5, it would make more sense to be 8.5 than 9.5. So if I had to take a random guess without a calculator, I'd say 8.5 squared. At this point, punch in your calculator. Make sure that we actually get 8.5 when we square root that. And you might not be surprised that we do. So, now the question wasn't, what is the length of a diagonal? It's what's the length of both of them. So, if one of them is 8.5, that's this one. This one is 2x. So 2 times 8.5 is 17. I look at my choices. It's not A, not B, not D. It has to be C. And there we go. Problem solved. Now, these are going to be the main types of equations you will see. Anytime we deal with an area problem like this, it's almost all good to identify the shape, throw down the formula for it right away, and see if you can use it to solve for your problem. Sometimes it'll be just as simple as that and you're good to go. Other times you're going to need to draw a picture. But either way, this is the types of problems you'll see. And that's all I have for you today. Till next time.